Alright, I'm going to talk to you about triangles, and everyone knows that triangles has three sides and that they have three angles, but triangles have specific names more than just being called a triangle. And those names are dependent according to the lengths of the sides of the triangle and according to the measures of the angles of the triangle. So I'm going to show you the different ways that you can name triangles, and then I'm also going to show you a couple of rules about triangles as far as the angles, the sum of the angle measures and the lengths of its sides. So the first thing I want to show you is a scalene triangle. A scalene triangle, by definition, is that no sides are equal or congruent. So every single side of the triangle, all three sides, they all have a different length. Then you have an isosceles triangle, and an isosceles triangle is when two sides are the same length. And these dashes show that these two sides are the same length. We don't know, excuse me, we don't know what their measure is, but we know that they are the same. Then you have an equilateral triangle, which by definition means that all three sides are equal or are the same length. I put two dashes here just to show you that all the sides with the two dashes are the same length. So since three sides have three dashes, three sides are the same length. It could be one dash. I just used two just to show you that it could have one or two or even three dashes. So this is an example of an isosceles triangle because two sides are the same length, and I'm naming it just by its sides right now. I'm not talking about its angles, just according to its sides. This is an isosceles triangle. This is an example of an equilateral triangle because three sides are the same length. And then this triangle here is a scalene triangle because no sides are the same length. Alright, now, so that was naming triangle by their sides. Now we're going to name triangle by their angles. And so every single triangle, it doesn't matter what kind of triangle it is, has two acute angles. It has two angles that measure less than 90 degrees. It is the third angle that determines whether or not the triangle is acute, right, or obtuse. So if the third angle is acute angle, it's an acute triangle. If that third angle is a right angle, it's a right triangle. If that third angle is an obtuse angle, it's an obtuse triangle. So here is an example of an acute triangle. Like I said, it has two acute angles. This third angle is acute, so therefore this is an acute triangle. All three angles measure less than 90 degrees. This is an example of an obtuse triangle. Again, it has two acute angles, but this third angle is obtuse, meaning this third angle is greater than 90 degrees but less than 180 degrees. And then we have a right triangle where, again, it has two acute angles, but this third angle is right, meaning it measures exactly 90 degrees. Therefore, this is a right triangle. So looking at this triangle, because, like I said, this is your acute angle, this is your acute angle, so this angle right here, because it's right, this means that this is a right triangle. And I'm just looking at it based on its angle measures, not its sides right now, okay? If I wanted to name it based on its sides, I really don't know enough yet, because if there's really not enough information given. If I said that these two sides were the same length, then this would be isosceles. But again, I don't know for sure. So all I could do is name this a right triangle. And of course, that is assuming too that this is a right angle, but it is. In this kind of triangle, this is here's my two acute angles, but because this angle is also acute, that means that this is an acute triangle. And again, acute angle here, acute angle here. This angle right here is obtuse, therefore this is an obtuse triangle. This angle is acute, this angle is acute. So now I'm going to look at this angle. If you're ever not sure, because when I look at this angle I think, well, it could be a right angle, it looks pretty close, you can use the corner of your paper, because you're usually going to have a piece of paper in front of you, and the corners of your paper are right angles. So use your paper, put it up here, and see how it compares. And you'll see that this is a little bit more than 90 degrees, so this is an obtuse angle. But using that paper will help you gauge the size of the angle. So this is therefore an obtuse triangle. Um, so now let's talk about, sorry, these are my notes from the other day. We're going to talk about the angles in a triangle. In all triangles, if you add them up, all the angles in a triangle, if you add them up, you will get 180 degrees every single time, regardless of the type of triangle it is, whether it's acute, right, or obtuse. If you add up all three angles in a triangle, you will get 180 degrees. And this is the visual that I showed you in class. I showed you guys a triangle, and then I tore off the corners and matched them up. But you can see here, if you match up all the angles, you add them up, that's 180 degrees. So if I folded this in here, sorry, this corner was folded down and I folded this corner in, this is what it, and I add those angles up, that's 180 degrees. They make a straight angle. And so that's proof to you that all three angles in a triangle are 180 degrees. And it works better if you tear the paper, if you tear the angles off and hold them together than folding them down. You can see it a little bit better, I think. So using that, you can calculate the missing angle in a triangle. So for this particular example, I know that I have 57 degrees. Sorry, let me write that again. I have 57 degrees, and I'm going to add 43 degrees, and then I've got whatever this measure here is x, that all three of these together will equal 180 degrees. Well, 57 plus 43 is 100 degrees. So 100 plus x is equal to 180, and then we can figure out that this missing angle measure is 80 degrees. So don't go by the look of it, because it's obviously not 80 degrees if you're looking at it. But according to our calculations, it's 80 degrees. If you are ever given angle measures and told to determine whether or not they form a triangle, you could add them up, and if it's equal to 180 degrees, it is a triangle. If it's not equal to 180 degrees, it cannot possibly form a triangle. Sorry, I'm going through this. Something else we talked about in class today was the length of sides, and I know I'm going through this pretty fast, but the lengths of sides on a triangle, the rule is that in order to form a triangle, the sum of the lengths of the two shorter sides must be longer, can't be equal to, the third. So in the example I've got right here, we've got this triangle. It's an isosceles triangle with lengths of 8, 8, and 9, whatever the unit is. The two shorter sides are 8 and 8. And the rule is, if their sum, which is 16, is greater than the shorter side, or the longest side, the two shorter sides are greater than the longer side, then it will form a triangle. And since 16 is greater than 9, yes, this would form a triangle. If I gave you these lengths, 10, 5, and 2, well, our two shorter sides here are 5 and 2. 5 plus 2 is 7. And since 7 is not greater than 10, these lengths would not form a triangle. And then just to show you how it works and why, let me do some moving around here. I cannot take these two sides. I kind of moved it and I was trying not to, sorry. I can't take these sides. I was trying not to change their side and move it around. I can't take them and form a triangle. These three sides, because by definition, somehow this angle or this vertex, this point needs to meet this point and make a vertex, right? And so that's not going to happen with these lengths. So again, the rule is the sum of the two shorter sides has to be longer than the larger side, the third side. Okay? So if I asked you the question, will the lengths 19 centimeters, 14 centimeters, and 28 centimeters form a triangle? The answer is yes, because 19 plus 14 is 33, and since 33 is greater than 28, the answer is yes, this will form a triangle.